Very warm welcome to Ritu Maths classes. Today we are going to do some more practice on the questions of properties of determinants. It is a topic from class 12. We had discussed the properties of determinants in very detailed manner in my previous video, and if you have not seen that video, please go through that. I have given that the link for the same video in my description box of this video. So let's continue doing some more practice because it is such a topic which comes only with the practice. So I have taken up question number 7 of exercise 4.2. By using properties of determinants, show that this whole determinant gets this value. Now let's start with the proof. I have taken LHS. Obviously, we cannot take RHS because no applications of properties can be available over there. So I have to take LHS only. Taking A, B, C common from R1, R2 and R3 respectively. When I say taking ABC common from R1, R2, R3 respectively means we are going to take A common from R1. So as you all can see, I can take A common from R1. So the R1 is left like this. I am going to take B common from R2. So B is outside, common factor, and R2 is having these terms now. And C common from R3. C is written out. So R3 is somewhat like this. Again, when we look into columns, we can take common. So again, taking A, B, C common from C1, C2 and C3 respectively. I get already A, B, C are there, and when I am going to take it common, so they are going to be A square into B square into C square. I have taken A common from the whole first column, B common from second column and C common from the third column. Let's apply some more properties. As you can see in the first two entries of the first row, minus 1, 1. So if I add them, it will give me a 0. So I am going to apply the operations C2 such that C2 plus C1 and C3 such that C3 plus C1. It means the first column is not going to have any transformation, rather it will be added into another column. So I am going to write it as such. No change in first column. Now let's add C2 and C1. Minus 1 plus 1, 0, minus 1 plus 1, 0, 1 plus 1 becomes 2. So I have used this operation only till now. Let me do another operation, C3 such that C3 added with C1. 1 minus 1, 0, 1 plus 1 is 2, minus 1 plus 1 is again 0. So we can expand it along R1 because we have two entries as 0 only in the first row. So the expansion will be really easy. Expanding along R1, minus 1, I have taken the first entry in R1. So leaving that row and that column, I am left with this subdeterminant which gives 0 into 0, 0, minus 2 to the 4. Next entry is minus 0 plus 0. So I am left with this. Minus 1 into minus 4 gives me 4. As you all know, constants are written in front first of all and then the variables. So I have got 4a square, b square, c square in RHS. Hence proved. Let's start doing some more questions. I have taken up question number 8 of exercise 4.2, first part. We have to prove that this whole determinant takes up this value. Let's start with LHS. Note down the elements very carefully. Since 1, 1 is present in the first column, so I'll start making it zeros. I have used these operations. No change in R1. Then R2 goes to R2 minus R1. Corresponding elements will be subtracted. 1 minus 1, 0. B minus A. Here I get B square minus A square. Then R3 minus R1, 1 minus 1, 0, C minus A, and the last entry would be C square minus A square. If you look at the last two entries of the third column, they can be factorized. So I'm going to factorize them. Very easy factorization is possible. So that I've taken. Now taking B minus A common from R2 and C minus A common from R3. We are left with this determinant 1 A square in the first row, 0, 1, B plus A in the second row, 0, 1, C plus A in the third row. If you want, you can go for expansion, but I will still prefer using another property. R3 goes to R3 minus R2, as 1 minus 1 can be 0. So let's start doing it. B minus A into C minus A as such. No change in first row as well as second row. Only the transformation will take place in the third row. 0 minus 0, 0. 1 minus 1, 0. Here when you subtract, A minus A will get cancelled down and you will be left with C minus B only. Now we have got such a determinant whose lower triangle is consisting of all the zeros. When I say lower triangle, it means the elements below the diagonal are all 0. And the determinant of such a determinant, the determinant value is very easy. It is simply the product of diagonal elements. So this can be written as this much. I am going to take negative common from the very first factor. B minus A can be written as minus of A minus B into C minus A as such, and again taking negative common from the last factor. Negative is positive, so I am having A minus B, B minus C, C minus A as required in the question. Hence, let's start with another question. Question 8, second part, where we have to prove this determinant is equal to this using the properties of determinants. So I am going to start with proof. I have taken up LHS. As you all can see, I am having 1, 1, 1 in the first row. So I'll start making them zeros, and simultaneously I'm having a look on RHS where I leave the factors A minus B, B minus C, which can be made by these operations, these properties. I have kept these same first column as the same, so no change. C2 goes to C2 minus C1. So corresponding entries have to be subtracted. It gives me the factors of this form. C3 goes to C3 minus C1, 1 minus 1, 0, C minus A, CQ minus AQ. If you look at these two entries in the last row, these can be factorized by using the formula BQ minus AQ is B minus A into B square plus A square plus AB. Here I am going to use CQ minus AQ, that is C minus A into C square plus A square plus AC. Let's take some common factors out. Look at this second column carefully. B minus A can be taken out. No change in first column. I am writing it as such. Second column I am going to take B minus A common. So the entry will be like this. And C minus A common from the third column. So the entry would be something like this. I have got almost two factors out. The negative positive signs can be rectified in the last. Again I can see 1, 1, so which can be made into a 0. So I am going to make it C3 such that C3 minus C2. So no change in first column, no change in second column. They have to be written down as such. Only the third column is going to take the transformation. 0 minus 0, 0, 1 minus 1, 0. And when you subtract these two terms, it is C square Plus a square minus a square cancels down. Plus AC minus b square minus AB. So again I've got such a determinant whose upper triangle is 0. When I say upper triangle, that means all the elements above the diagonal are 0. And the expansion of such a determinant is really easy. It is simply the product of diagonal elements. So I'll be simplifying it further. It is equal to b minus a into c minus a into this whole factor 1 into 1, so it remains the same factor. Let's sort it out. I've written down c square minus b square, then plus ac minus ab. I've just rearranged the terms. b minus a into c minus a. Again making the factor form of c square minus b square as c minus b into c plus b, and a common from the last two terms. Look at this carefully. C minus b is present in both the terms, so it can be taken common, and the internal factor will be c plus b plus a. Let's rearrange it. I'm going to take negative common from the very first factor. Then c minus b I have written down, so I am going to take negative common from this also, and last is a plus b plus c. Negative into negative becomes positive, so I am left with a minus b minus c minus a into a plus b plus c as required by the right hand side in the question. Hence proved. Thank you. So if you have liked my video, please like it and share it with your friends, and do not forget to subscribe to my channel Ritu Garg Maths Classes. Thank you for watching.